Hello, ladies and gentle ladies. Welcome back to another railroad development stream. Today we are going to be continuing with the Java parser. And yeah, it's been a while since we have done the Java parser, so hopefully we're going to get back into that today, now that we have done we've released the first public test. So yeah, we're going to have to try and figure out where we left off, because honestly, I'm not sure. So we need to do that. But first, I need to announce in Discord that we are live. Okay, so let's go ahead and get started. So, last time, we actually got quite a lot working, I believe. I don't remember if it was last stream we got a bunch working, or if it was the stream before that stream. And by last time, I'm not referring to the last stream, I'm referring to the last time we did the parser. I think we got a lot working, or maybe we just fixed errors last time. That's possible too. I think that's what we're going to be doing today as well. So let's go ahead and run the SST testing, and then we can see kind of where we're at. I think there were some issues with types. Maybe I can actually even find the to-dos in here. Yes, we did have that issue. That's going to be a big one. We do need to do that at some point. Yeah, we need to look into that. Don't know when or how, but we do need to do that. Oh, also, let me quickly do that. There we go. Yeah, okay, so yeah, the semantic analyzer can obviously do that. I don't see why that would be a problem. And then yeah, so we just have that one, and that one. But let's see what it's gone ahead and output for us here. So, oh, why is this not being called? That's interesting. Why is that not being called? Uh-oh. Well, I guess we have finish method invocation expression, which is actually probably what we're using. Yeah, so there's that one, which is for generic methods, and then we have this one, which is for normal methods. But for some reason that's actually just not being called, which isn't correct. I don't know where that's gone. And I guess it's here. Let's open parenthesis. I guess, technically, I mean, this one needs to be This is when it matches the open parentheses. So if we look at this in here, yeah, that does all of that. I don't think we need this method. I think we can actually ditch that method, surprisingly, which is a little bit weird. Okay. I think that's fine. Okay, let's see what this has produced. So the code that it is running is... it is running this file. So this SST testing file. Okay. Now, there was a couple issues, I believe, with types. So let's try and find a way to split, and then we can view them both at once, kind of side by side. So, package declaration, those are all fine. Is this one fine with the wildcard? Let's have a look. Is wildcard true? Yes, okay, that's fine. So then we have the type declaration. So obviously we have a class. That's actually the only type declaration we have. So that's defined. That has a modifier. It has a name. Oh, yeah. Okay. Then we have members. So what do we have in the members? We have a field, which is private, static, and final. Yep, we have a boolean, include span, and that should be just equal to false. Yes, that's correct. Then we have a public static primitive type ref, yes, void main, and the parameters, it should take in a string array. So that is an array type of a class or interface type of a string, and it's one dimensional. Okay, so that's correct. And then we have thrown types. It should throw a class or interface of IO exception. Okay, that's correct so far. I'm pretty sure the method calls are already correct, but I guess let's have a look. So we have an expression statement, which is a method invocation expression, which is a field access expression, which is system.out. And then we are calling print line, and then the arguments for that is a string, which is SST testing. Okay, that's correct. Then we have a local variable declaration statement, which should be this one. So the type is a string, which is a class or interface. Correct. The name is code, and then the init expression is a method invocation expression. Interesting. So in the method invocation expression, it's just got files, but this is a name, and that's correct. This is a name, but well, yeah, I mean, I was going to say it's technically a type, but I guess it's not. I guess as far as this is concerned, it's a name. Sure. Okay, so we're doing files dot read string, and then the arguments is a method invocation expression of path dot of. It's just taking in that. Okay, that's fine. Then we have another expression statement. That's going to be fine. We have another expression statement, which I think is also fine. Okay, then we have the try statement. I think this is where things started going a little bit haywire. So in the resources, we have a local variable declaration statement, which is a primitive type. Technically true, Ugh. I guess kind of true. Sure, true enough. So that's a var. Is var true? Declarations is a variable declarator. Yeah, the name is Lexa. The init expression is an object creation. The type is a class or interface type of a Java Lexa. Correct. And then we're passing in code. Okay, then in the try block, we have a local variable declaration statement, which is part. No. It's a local variable declaration where the type has two parts. Yeah, so there's two parts to the type. Okay, yeah, that's correct. These are both name expressions. It's kind of not true, but it also kind of is true, so I guess that's fine. So that's lexa.snapshot. Oh no, I think that is fine, actually, because it's saying that this is the name. It's not looking for the type, it's looking for the name. Okay, so lexa.snapshot, and that is equal to method invocation lexa.snapshot, and then while true, we go local variable declaration statement. Okay, now this is, I think, where things started to mess up. So the type of that is a class or interface. Correct. And then that's a token of type arguments, class or interface of a Java type token. That's correct, actually. That is called token. That is equal to a method invocation of lexa.next token. Okay, so far so good. Then we have this if statement. So, oh wait, no, we have this one first. But we don't care about that one because that's fine. Then we have an if statement, which is a binary expression. And the left side is a method invocation, so token.type, operators double equals, and then the right hand side is a field access expression, which is Java token type.uf. That's correct as well. Then we break, that's correct. Okay, then we have a method invocation expression, which is Lexa. At lexa.restore, yeah, lexa.restore, taking in snapshot. Okay, we have a print line, which we know is going to be fine. We have a local variable declaration, which should be fine, but we can check. So that is a var called parser equal to a object creation of Java parser. Taking in Lexa, hopefully. Yes, correct. Then we have another local variable declaration, which is this one. That should be fine. That should be fine. That should be fine. That's fine. This one, let's have a look at this one if we can. Let's find the try statement. Here we go. And then we have local variable declaration, which is the first one. Then we have expression statement, which is the second one. And then we have the third one. Okay, this is where something's going to mess up. This looks quite complex. Okay. So in here we do method invocation. Yeah, okay, so this is where things started to fuck up. So basically what's happening here is it thinks that the scope of this is print AST. But in fact, that's actually the method name. And so the arguments, it has actually kind of worked. I mean, the arguments here are AST, an empty string, and hopefully an object creation of a new print stream, passing in a method invocation of files.new output stream, passing in a path. So that actually has kind of worked, I guess. The only issue is it doesn't know the method name. Which is interesting. Interesting. Okay, let's have a look then. Let's try and find where we're passing that. So if we find method invocation expression and we go, sure, let's look at this one for now. Okay, this is the one we were literally just looking at actually. So we create a new method invocation expression. It's in the start. Okay, so this is where it finishes. But where is this actually called? So if I open, I go find usages, we can see all the different places this happens. So for example, this one is in postfix. Okay, so we know it's not this one. And the reason we know it's not this one is because this one takes in the name as a parameter. And the name was null. So it's actually this one where, okay, this one is the issue. This should never happen though, in reality. We should never get here is kind of the issue, I suppose. So I think what we need to do is we need to look at where name is being created. So I think we actually have a to-do for this, don't we? Yes, so this is just a primary expression. Okay. So in here, we need to be able to handle field accesses, method calls, array access, and anything else basically that starts with an identifier. So yeah, so I'm kind of thinking, should we do that somewhere higher up? Like, is that really a primary expression? Not really, right? Where do we handle normal field access, I wonder? Because for example, in like when you do, for example, you know, system.out, that's a field access expression, but that's also just a name. It's just an identifier followed by another identifier. So where am I handling that? Because if I can find where I'm handling that, which is apparently in postfix, if match dot, yeah, I see. And I guess the issue here is that we don't have a dot. Okay, in that case, I guess we have to do it here. Ugh. Okay. No, we don't do it here. No, that's the entire point. The entire point is that we don't do it there. The point is that we do it here. So if next is an identifier, we need to take this identifier and do something with it rather than just returning it. So we need to look at what the hell the next token is and use that to figure out what to do next. So for example, we can start by making this a variable, which will just be name expression, Sure, whatever, I guess. Okay, then we need to see what the next character is. So if next is any, or I guess we can match. So if next is an open parenthesis, then we need to do this. Is that correct? What it's done here? So that'll be finish method invocation. That's the expression. Then yeah, that's correct. Okay, the next one is if we match a dot, open bracket, double colon, and it returns name expression. Can you put some Adam Levine? No, Wide, I cannot do that. I have to tell you this every single time. Okay, if next is dot, do we need to handle array access, actually? I don't think we do we? I think it is just method calls. I don't know, bro. Maybe they changed the rules. But if we were on Twitch, then yes, I could do that. Because you can just play whatever the fuck you want on Twitch. They don't give a shit. But YouTube, unfortunately, is a little bit stricter than that. So that's not the case here. Next is any double colon pass a method of reference expression. Yeah, I mean, I don't think that should be happening here though. Question. When does this happen? When is this called? If next is an angled bracket, which happens in postfix. Okay, so I don't need to do that. Likewise, I don't think I need to do the double colon for method references yet because that's done there. And I don't need to do open brackets because that's done there. Oh no, maybe I do. Oh no, no, I don't. So it is actually just this one. And basically else, we just want to return the name expression. And I think that basically should solve it. So let's have a look. Okay. So if we go into AST outputs, let's split it again, like that. Okay, so method invocation. Where is this? Print AST here. So the method name is now print AST. There you go. Passing in AST is a name. Object creation expression, blah blah blah. We know those are fine. Okay, let's get down to where the generics are, because I think that's where we had a little bit of a problem last time. So we have the catch clause, blah blah blah. We do not care. Okay, then we have a method declaration, which is this one, which has a single member annotation, which is called suppress warnings, and the value is unchecked. Okay, that's fine. Wanted to check that that wasn't a problem. I think all of this is fine. Oh no. So we have a couple things that might be an issue here. So for example, this OR here might be a problem, I imagine. Like this array followed by an OR could be a problem. And I think these wildcard generics were a problem as well. So we're going to need to go through this method a little bit more vigilantly. So what do we have? We have parameters, don't care about those. Okay, we have an if statement. so we have if node is equal null, then return. We have method invocation, so that is out.println. We're passing in 2 binary expressions, which left is indent plus this as a string, and then plus the right hand side, which is method invocation, which is node.getClass. Oh yeah, okay, a nested method invocation. So node.getClass dot get simple name. Okay, I see. Okay, then we have the enhanced for statement. So what do we have here? This wasn't correct last time, actually, was it? We have a local variable declaration, which should be field, and that is called field. And that is set to node.getClass.get. Okay, that's fine. What does it do inside? We have a normal expression statement. We have a try statement. Inside the try statement, we have a block, of course, which has a local variable declaration, which is this one. Then we have another local variable, which is this one. Then we should have an if statement, which is this one, which is a method invocation object.equals method invocation field.getName and a string little children. Then it continues if binary expression of a unary expression, so not include span, and objects.equals field.getName. And okay, this all looks fine to me. Then continue. Then we have another if statement, which is now this massive chunker. So let's go here. There we go. Now we can see them both. Okay, so if value is instance of a array type of a class or interface, so string array. So if value is instance of string array, that's correct. Or this should be a parenthesized expression. I don't know why it's not. Okay, either way. Binary expression. Wait, why isn't it, actually? That's kind of weird. Okay. Okay, either way. The left is an instance of, so value is instance of a class or interface, which is list, which has the wildcard, which has a type preference of a wildcard. Okay. And then we are calling that list, and method invocation is list of strings list. Boom. Okay, that's good. That works. So all of that line actually does work. Then we have a list of strings. So list of so class or interface list type argument string called strings, and that is set to a conditional. So this is a ternary statement. It is. Okay, does this work? Because there's like casting and shit going on here. So we have value is instance of a string array, one-dimensional, which we are calling array. If that's true, then we call arrays.asList of array. If it's false, then we're doing a typecast. So that is a list class or interface type of type arguments string class or interface type, and we're casting that to value. Okay, that's mega. So that actually all works. This entire if statement, surprisingly, even though it's quite complex, does actually work. I'm quite happy with that. Okay, what's next then? So then we have... then we have the print line. Okay, so I think that's all fine. That's just a bunch of pluses. Then we have the else statement, which has an if statement, which is if value is instance of a class which is called AST node, which we will call child node, then we do a block statement, which is a method invocation. That's fine, hopefully followed by a continue statement. Oh, no, it's this one. Never mind. I was looking at this one, but it's this one. So it's two expression statements. Those are both fine. They're just method calls and some pluses and stuff. That's nothing that wouldn't work. Okay, in the else statement, we have another if statement, which is going to be this one. So we're going to say if value is instance of a class called collection, which has the wildcard type parameter called collection, then if collection dot is empty, then we do out.println. Okay, that's fine. And then a continue statement. Then we have another expression statement, which will be fine. We have an enhanced for loop. Let's have a look at this one. So local variable declaration, which is a object called item that is set to, or that is the iteration expression is collection, which is this. And then if item, that will work based on everything we've just done. That will work fine. So we can come all the way past that, which gets us out to out.println. I think this one. I think. Yeah. And then we have this one, which should all be fine. Optional of wildcard class interface called opt. Yeah. Okay, the only other thing we can check is this final one down here, which has a method reference. And then if that all works, then we have successfully passed this entire Java file, which is actually kind of crazy if that works. So let's have a look at this final method down the bottom. So here we go. Okay. Here we go, method declaration. So private static boolean called is list of strings. In the parameters we have a collection of wildcard, which is called collection. In the body we have an if statement of a method invocation statement, which is collection.isEmpty. Then we return false. Else we go ahead and return Oh, yeah. Okay. Yeah, it's not an else statement, but it is the else. Because this could be a ternary statement, but that's besides the point. Method invocation expression of a method invocation expression, so that is collection.stream.allMatch. Then we have a... Oh, this actually hasn't worked, unfortunately. So what's happened here is it's found string and it thinks it's a field access expression, when in reality this should be a class expression or whatever it's called. Class literal, I guess. Okay, let's breakpoint there and see what happens. Never hits it. Interesting. Okay, interesting. So, very, very interesting. That makes this kind of hard to debug because this is in primary expressions, of which there are hundreds of in here. What does this do? Expects a dot and then a class keyword. Oh, but it passes a type preference first. Right. I see. Okay. I see the problem. I entirely do see the problem. Okay, the interesting part is that it's got down to a primary expression. So that we know that means it's happened here, weirdly enough. So for whatever reason, it's found the dot, right? It's found that dot, and then it's gone ahead and it's said, okay, I see the issue. So what we need to do is we need to say if match no, that doesn't work. Okay, we need to then look in that case at field access expression. So what it does is it finds the dot, right? Well, actually, okay, let's have a look in that case where field access expressions are even happening. Okay, that's in postfix. If next is only an open parenthesis, then expression is equal to field access expression. Interesting. But something is causing the expression statement to be null. Wait, no. No, it's not. The name is null. the name of the field access expression is null. So this name right here, so what is that set to? It's set to name expression, which is equal span from name list of name.lexeme. So that means this isn't working. Let's go ahead and do sout. Sure, let's just do that for a second. Okay, so yeah, look at that. It finds empty parts. Huh. Okay. Interesting. Okay, what we could do is sout name %s and expression %s. That'll tell us to do printf, of course. And then that means that we can see what the expression is, which is a name expression of string. Okay. Right, because it's trying to then find a name, and it's actually finding a class. So I need... Interesting. So what that means is basically the parse class literal shouldn't be here. It should actually be... here. Right? I think? Maybe? No. Wait, that won't work. Because it needs to happen before this. So where is this called? Here. This is in unary expression. Right, I see, because it should pass the primary expression. And so it should, if we go back to what we had before, which was this, it should find this and not this. So for whatever reason, it's not hitting this, and I don't know why. The only problem is that's really hard to debug. Like, insanely hard to debug. We could try breakpoint and check if the current pos is 5095. Maybe. So if we breakpoint and say this dot, how do we get the pos? Shit. We can't get the Lexa, can we? We kind of can, but the Lexa isn't going to have the right pos. So we could, no, we could say look ahead 1, which actually we have a peak method, don't we? No, apparently not. Look ahead 1 dot pause is equal that, and it might work, maybe. It's a long shot, admittedly. Oh, okay, it has actually stopped. So what's it found? It found an open parenthesis. What? Oh no, that's the previous token. That doesn't make any sense either. That doesn't make any sense. Connect is only a dot. And then if the next is not an identifier. So what is the next one? Look ahead 3. So we're going to fill the buffer. So then we'll do the next token, which is class keyword. So that means it returns. So the next type is class. And then it's looking through the types, which is identifier. So it returns false. And so that makes that true. I think this is meant to be if next is any at. Next is an ident. No. Huh. I guess I can say if next is any at offset, or we can put this here. And say a class keyword, which is like that, then return true. Right? I think that fixes it. That means it has to be an identifier dot class, basically. And if we look what that does basically elsewhere, so it's basically while it matches a dot, if it's a class, it's true. Else, if it's not an identifier, then it's false. And basically, it just continues from there. And then if it doesn't match a dot, then we look for left angle brackets. And if we don't match an identifier straight away, then we need to look and see if it's like an int, a char, a byte, etc. Yeah, I think that's correct. So let's go back to where our breakpoint is, which is right here. And let's just give a normal run. And that causes it to print all match. Okay, that might have worked. That might have worked. Maybe. Let's try and find where that print statement is so we can get rid of it. This system. Out. Yeah, there you are. Right. So that hopefully has caused this to now give us a method reference. So we have a method reference expression of a class literal expression, so that is string. That's not quite right though. I see, because it finds a string and then it finds the dot. It does find the is instance, admittedly. That's the problem, because it finds the friggin' dot. Because it doesn't know whether it needs to pass it as, like, for example, string dot, you know, sub class, or if it's just looking for string dot class. It doesn't know if it terminates at that. The only way to fix that is to look for parse name, which doesn't exist because of course it doesn't exist. New name. No, I just want to find the normal name expression, which means I need to look at parse primary, which is here. So the next is identifier. Next is an identifier, and we take the identifier, we get the name expression. No, that's not right though. No, that's not where it's happening. It's happening because of parse class literal, because that's doing parse type reference, which is parsing the type, and this one, and then in here, whilst it matches a dot, it reads them. So I need to know if it matches. Basically, I need to see if it matches a dot and not a class after. But in that case, I don't want to consume the dot. Or do I want to consume the dot? That's a lovely question. Let's have a look. Well, actually, I guess we don't really care, do we? And next is not super this and class. Yeah. So that's able to then return that, which returns that. Now, how do we find? Probably that one. And then we have to find the one we want, which is going to be up here somewhere. Probably this one. Not that one. Okay, let's try and find parse postfix primary. Primary will do. Parse class literal. which does that. That expects a dot, but we could also just do if previous dot type is not equal to dot, then expect a dot, basically, which I think is fine. It's maybe not perfect, but I think it's fine. And that just means that now it's just string of a class literal. So string dot class, and then we're calling is instance as a method reference, I mean. Which means this entire class is now successfully parsed. Boom. Okay. Now this is where I need you guys. I need you guys to send me some code. And I need to see if it passes the parser or not. So if anyone has a class they want to submit, then I guess paste it in. You won't be able to paste it in you won't be able to paste it in YouTube chat though. I don't know, just put it on my server somewhere. Would be the easiest way. In the meantime, I was gonna say I can try some classes in here, but I guess that won't really work. You know what I could try and do? I could try and parse Java parser and basically see if we have any null in there. If there's any nulls, then it won't have worked. So I guess let's try that. This seems kind of silly, but here we go. So source main Java, IDE SST. We need to go impl / Java / Java parser. If we can parse our parser using our parser, then we know our parser works, right? I feel like that's perfectly reasonable. So let's try it. It could even just crash. Okay, it hasn't worked. We have a null here. So interesting. Whoa. Where? So name expression of parts $sign. What the fuck? How has that happened? I'm actually more curious how... Oh no, I guess that's technically allowed in the Alexa, isn't it? Oh no, that's correct, actually. I see what it's trying to do. So it's trying to pass a lambda, and it's failing to pass the lambda. So if we search for try parse $sign... Okay, no, that is definitely a thing though. Oh, not in this class. 1 second. On class. Control find. So it's trying to parse this one. Okay, so it just can't parse lambdas, basically. So let's try and figure out why, I guess. So variable declaration. Oh yeah. Okay, so a local, so a lambda expression. The name is called lambda expression. That is being set to a method invocation expression. That's correct. Which the name of the Variable? No. Oh, I see. It doesn't know. So it doesn't know how to deal with lambdas as parameters, basically. Okay, so it basically finds. It finds a method invocation. Oh, I see. I see. So it finds the $sign, right? So it figures, okay, we found an identifier. Then it finds a minus, right? So it thinks you're doing one thing minus something else, which means that that's why the right side is null, because it doesn't know it's a lambda. It can't pass the this right angle bracket as a you know, an expression, so it's null. So basically we need to look at why lambdas aren't working. The funny thing is I think it's actually just failed in this method. I think this is actually like where the issue is, which is kind of funny that it's failed trying to pass a lambda because the code that passes the lambda is wrong, but it failed there because there's a lambda there. It's stupid, but that makes sense. The question, I guess, is why? Okay, let's look at parse parameter. Because maybe parse parameter isn't passing an expression? No, not parse parameter. It needs to be parse argument, or or is it parse parameter? It's method calls, right? So method invocation expression. This little sucker. One of you. Which one of you is it? It's not going to be that one. It's going to be this one. So what does this do? So it takes a list of arguments whilst it's not a closed parenthesis. Oh no, if the next is not a closed parenthesis, then it passes the arguments, and that just passes an expression. So I was correct. That means it's got to here and it's just said nope, not a lambda. So why the fuck not, I guess, is the big question. Let's have a look. So if next is any identifier and the next is not an arrow. Interesting. Oh, you know what that means? That means the issue is actually the lexer, funnily enough. And that's why. That's why. Because it thinks an arrow is an equals plus a right angle bracket. It's not. That's not even a thing in Java, right? Java doesn't have that. I know it is in JavaScript, but I don't think Java has that. So that's probably why. Can we have a look? Okay, it got a little bit further, I think. Did it? Did it? No, it actually hasn't. Oh yeah, because it's still found a minus. Oh, because I put it in equals. We're just going to ignore that. Let's ignore that, guys. Okay. We're going to ignore that. Let's try again. Hello? Oh, because of that. I'm sorry, I didn't mean to upset you. Oh, we got an error. Uh-oh. Interesting. Range 2, out of bounds for length is 0. Trying to pass an integer literal. Interesting. Wait, do you stream on Twitch too? No, I'm not streaming on Twitch. I used to, but it just didn't really work. I thought it told you what the string was when it failed like that. Okay, did the Lexa finish? Yes, it did. Pause 115,115. That's crazy. This is a massive file. Okay, so range 2,0 out of bounds for length 0. Okay, let's put a breakpoint in there and see what's happening. So the lexeme is empty. What do you mean the lexeme's empty? How the fuck is the lexeme empty? What do you mean the lexeme is empty? Oh, wait, it's a missing token? Wait. I don't understand. It's a number, so it's a number binary literal. But why is it a missing token? I don't remember what a missing token is. So let's find new missing token. Okay, that is a thing. Oh no, it's not a thing because it's something dot missing token. Token dot missing token. Okay, so it's one of these, I guess. Not that one. Expect any. No, I don't think so, because I think it would have said somewhere. I mean, actually, for the most part, these all look correct. Like, all of these are simple tokens. So obviously, it's failed further up, where it's hit a missing token. I don't see any, though. Which is kind of weird. Oh, no, because that's a parser. So what is that saying? That's saying... So it's this, basically. It's basically saying that it's expecting that, but it hasn't found that. Okay, I need to make this not a single line. Holy shit. Expect. Next is any. Yeah. Okay, so plonk you on the next line. Expect you. No. Expect you. Or. You. Or. You. Or. Holy shit. You. Okay. So it's basically expected. What did it say? It's actually like expecting, because it did actually say, didn't it? A number binary literal. Next is any. Number binary. How the fuck is it trying? What? Why is it trying to find a number binary literal? Okay, how can we go to pos 3092? I guess we can go to the line and the column. So 137.51. So let's go to 137 column 51. 137, and of course it's not there. Okay, is there any numbers here anywhere? No. What? Okay, let's try again. Maybe it's bugging out. So 137.52. What? Line 137? What do you mean? There's nothing there. And there's not even like anything near it. Like there's no numbers anywhere here. I think actually the pos is more reliable than the line and the column number. I'm not 100% sure. I could be wrong. But I think that is the case. I don't know if there's a way to like go to a position or not. I don't think so. Like what does this do? Not what I want. IntelliJ, go to character position. Okay. Apparently, it's not a thing. Apparently, there is an issue for it to be a thing. But it's not a thing. Oh, I see. Apparently, it's not a thing because... Okay, there is a way to do it, but like... I kind of want to try this, actually. I'm very curious. Edit custom properties. Apparently, you can add this. And apparently that means that you can just put it in there. I probably have to restart the IDE. Can I just like... I guess I can do that. Just restart. I'm actually curious if this works. Only problem is we are going to have to run it again, but we now click on that, hopefully. Yeah, look at that. That's kind of crazy. Okay, so if I go ahead and run that again. Okay, so the position is 3093. I go in here and I go 3093. Okay. That doesn't help, does it? That makes even less sense, actually. Okay. Interesting. Let's hit it again. Yeah, let's hit it again. And then let's come in here. And go... like, in here. Is there anything? So, it said here, expected semicolon after expression statement. So, immediately that's an issue. So, that's 103.86. Interesting. Let's go 103. Hopefully this one's correct. 103.86. 86 is not going to be on that line. Okay. Does it have a pause for that? Instead? 2459. Okay, 2459. Apparently right here. That doesn't make much sense either. That makes me think that most likely it's still being caused by the lambda. Well, it is, yeah, we know it. Well, no. Do we know it is? I guess we don't know that it is. But it could be. And then it's expecting an integer literal for some reason. What's in the look ahead buffer? So it's found a number int of 1. Wait, didn't we just see a 1 somewhere? We just went to somewhere that had a 1. Maybe... okay, but that doesn't actually really solve the issue though, does it? So why is this happening? If int_token.type is equal to number binary literal. But it's not. It's an int literal. Int token. So expect next is any binary literal, number hexadecimal, int literal, number octal. If it does, then it's a binary literal. What? That doesn't make any sense. Why did I do that? I think what this meant to be is a binary literal. So if it's a binary literal, then it's a binary. Wait, that doesn't make any sense though. Wait, what? If it's a binary literal, then it's a binary literal. If it's a hexadecimal literal, then it's a hexadecimal. This doesn't make any sense. This is stupid. Oh, no. That does make sense. Because it's basically saying that's the type it should consume. So if the next character is a binary, then it needs to consume a binary. If it's a hexadecimal, it needs to consume a hexadecimal. If it's an octal, it needs to consume an octal. Else it needs to consume an int. That's what it should be. So I think if we debug now, in theory, it should skip past that part. Oh! Okay. Okay. No errors, and the file is significantly longer. I suspect there's going to be a null at the end, though, because I don't think that's long enough. It's long, but it's not long enough. 4,000 lines for let's see how big this file is. 2,765 line file. There's no way that it's only going to be 4,000 lines. So yeah, it should be like, I don't even know, like 20,000 lines probably. Okay, so let's have a look. So lambda expression, the name of the parameter is $, which is inferred. That's correct. The body is a method invocation expression called parse lambda expression. That's correct. Okay, let's continue then, and let's kind of go down. Let's go to the end and just have a look what it thinks it's found at the end. So it's found additional bounds. So let's search in here for additional bounds. Okay, yeah, as suspected, it has only got to line 274. Oh dear. So even after 4,476 lines, it has only actually got to line 274. Oh my god, this is crazy. Okay. So while we match an... So, okay, wait, what is the issue? Oh, the issue must be this. It must be this, right? The init expression is empty, apparently. Yeah, I think that has to be the issue. And if we look at what's before it, oh wait, no. Wait, no. That's not... It can't be that. It can't be this. Is it this? So a local variable declaration statement. Okay. The type is a list of type ref. And then that's called additional bounds. Okay, yes. And that is equal. And it doesn't know what to set it equal to. Interesting. You know, that's not what I expected, because don't we have anything like this in here? No, apparently not. Interesting. Okay, so basically we need to look for where it tries to pass diamonds, and then kind of go from there. So it should be able to find an object creation expression, but we can have a look. So if we go into God, pass variable, let's just go into here. Pass variable declarator. Okay, go into here. So if match equals, now question, is that actually equals? Yes. Okay, good. So if match equals, then it is equal to an optional of nullable pass expression. Okay, that's fine. So then we need to look into pass expression and try and find where it reaches a new keyword anywhere. So assignment, conditional, logical, bytewise, quality, relational, shift. Yeah, it's not going to be shift. Additive, multiplicative. It's probably going to be primary, actually. I'm pretty sure. Plus, yeah, it's not going to be any of these. If next is any, plus, no. If it next is any open parenthesis, no. So then we go postfix. And then it should pass primary. If it matches this, no. If it matches any literal, no. If it matches open parenthesis, no. If it matches a new keyword, it should come into here. So pass class instance creation or array creation expression. Okay, so it should then pass. Okay, let me actually breakpoint that. Yeah, let's breakpoint it. And just see where we are right now. So if we look at previous token. I'm a little bit suspicious of this diagnostic though. It's expected semicolon. I don't know why that's happened. Somewhere I must be trying to consume a semicolon when it's already consumed or something. I suspect that's all it is. So previous token is new, which makes sense. How can I whittle this down? I don't know. I mean, ideally, I would obviously go up the tree, up the stack trace basically, and try and find. Okay, what are we inside of, right? But like, you can't really do that. I mean, you kind of can, but not really. We could do a look ahead, maybe. Yeah, that's probably the best way to do it. So if we add a breakpoint and we say look ahead of type 1, or yeah, look ahead 1 dot lexeme dot equals array list. Okay, and if I do that and then press play, we should find where we are basically. So in the look ahead is an array list. So let's go next. So we pass the constructor type arguments. There shouldn't be any. That's fine. And then we pass a base type, which I think is where it should handle the diamond, I believe. So if we go into there, so it won't be any of those. So it'll be a class or interface. So we go into here. I see it doesn't actually handle the diamond in here. Okay. Oh, no. It should, because it passes the type argument. So if we go into here, so we match a left angle bracket. If next is any, a right angle bracket. So this should be true, but we'll step into it and see. So if we go look ahead of 1. Okay, then we go into here, and we grab the next token. The next token is a right angle bracket. So it should add that. And so that should be a right angle bracket. The types it's looking for should be a right angle bracket. Okay. So then it should just take the type diamond. I don't know why that wouldn't work. Okay. So it has type arguments. which is just a type diamond. Okay. Parts.get first.span. Fine, I think. Here's the type. If next is any, an open parenthesis, which it should be. Oh, it didn't consume the right angled brackets. That's why. So where type diamond, here it doesn't consume the right angle bracket. So let's try again, shall we? Okay, so let's go into here again and into here. Boom, 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 boom. Hopefully, boom, and hopefully the look ahead is empty. Yes, which means that when it gets to here, it finds an open parenthesis and passes a class instance creation expression. This one. Okay, and then if match left angled brackets. That's interesting. I guess that's fine. That just means that it hasn't gone onto the constructor, so it hasn't been passed as a. But actually, I think that's actually wrong in reality, because that's gone onto the type. So basically, the type now has the diamond, but yeah, that's actually not correct. If we actually look at this here, yeah. This is kind of correct. It's kind of correct. I need to know if the next is that, and then and not next is any at 2. A right angle bracket, basically. And then if that's the case, I just don't need to do that, and all I need to do is expect the left angle bracket, basically. That means it's an open bracket followed by anything that is not a right angle bracket, which should work, because that means that won't now be called from there. So I think that's fine. The only problem, actually, and I did just realize this, is the other place that creates the type diamond. Yeah, see, this one double matches, which is correct. So that's what it should do. Okay. What are you doing right now? Right now, we are trying to see how far we get. Unfortunately, however, that didn't work. I thought that would fix it, but that actually didn't, weirdly enough. So I need to know if lookahead1.lexeme.equals array list. Done. And let's debug again. Is it going well? Kind of. I mean, we've managed to pass quite a lot. We managed to pass like 200 lines, basically, of the Java parser. And I'm hoping once we fix this, it should be able to go a lot further as well. But right now, it's not too happy with that. So base type. If we have a look at base type, what are you? You are a class or interface, and hopefully that has no type arguments. That is correct. So, oh, bugger. Yeah. Because the next isn't an open parenthesis. It's a bracket thing. They called angle bracket. So if I also say left angled brackets, because you can't have left angle brackets on an array, right? You can't do like a new list of string array like this. You can't do that. Yeah, you can't do that. So that's fine. Yeah, that's fine. Okay, let's try it again. So if we go forward, so boom. So we get into here, boom. And then we match a left angle bracket. If we match a right angle bracket, then we do that. Boom. So hopefully the constructor type arguments now has a type diamond. Okay, hopefully the rest works, I guess. So let's press play. Okay, so we're now at 8,800. So we literally doubled from that. So that's presumably, I guess, in theory, going to be roughly around here. Roughly around line 400 and something. So the question is, what's it failed on this time? So where are we? So it's found an integer literal expression, and then it's just found a straight up null expression statement. What? So it's just found an expression statement which is just an integer literal. That's it. That's not possible. Interesting. Okay, let's search for 0. There aren't going to be that many of them. I doubt it's this. I guess that's line 500 though. So that would be about correct. But it can't be that. What was before it? Span from start lexeme. No, that's not correct. It's somewhere else. It must have got further than line 500 then. Is it a floating point or a... It says it's an integer, so it shouldn't be this. But we can look to see if it's wrapped inside of a floating point literal expression on. It is, actually. So it's found an object creation expression, and inside of the arguments we have a method invocation expression, which is span from start, which is this right here. Then we found the lexeme, which is just a name, and then it's found a field access expression, which means in reality the lexer has fucked up, funnily enough. Because that means the Alexa hasn't realized this is a float. It thinks it's a integer followed by a dot followed by an integer, which isn't correct. So I don't know why that would be the case. That's kind of weird. I'm surprised we've only now actually found that issue, but we can have a look. So Java Alexa, what are you? Whatever. So yeah, we need to find read white space. No. Read default. No. Yes, here. So current is equal to 0 and has next. Switch on next. So if it's X, okay, if it's B, if it's dot, then it consumes it, adds the next, and reads it as a decimal literal. I don't see how this could go wrong, I can't lie. So if while has next, char current is equal peak 0. Character is digit current. Okay, I kind of need to breakpoint this, unfortunately. And I think that's going to be a pain in the butt to do. What? What? How did that not hit? Excuse me? How the fuck did that method not just get called? If has next and peak 0 is equal dot. Oh, no, not that one. This one. If current is equal 0 and has next. Okay, I'm gonna have to breakpoint this then. So current is equal 1, don't care. Current is equal 1, don't care. Current is equal 0. Okay. So next is equal what? Next is a space, apparently. I don't know how that's possible. Why would there be a space after a 0? That doesn't make any sense. Does that make sense? No, that doesn't make sense. Next, well, has next. Next child dot peak. Oh, there's a 0 space comma somewhere in here, apparently. 0 space comma. Wait, did it not say comma? Or am I crazy? No, it says there's a comma. What? Unless it's saying it's comma? 0? Wait. The next is equal peak 1. Is that correct, or is it peak 0? It's peak 0, right? Because has next is checking pos is less than length. So in order to get the current character, basically, you have to peak 0, I think. Or am I getting confused? No, I think that's correct. But then even if we're going one ahead, let's say even if we're going one ahead, right? Which isn't correct. But even if we do that, that would only be another 0. I'm also really confused how it's not being put in the look ahead buffer. That's a little bit weird. Where is the look ahead? It like, is that not even Alexa? Is that end? Is next token type? Is next token type? Okay. This should be being used though. Is next token type, which is called oh. So if I look ahead buffer, add last, produce next, which no, that's not what I'm. Wait, I'm getting confused. I wrote this so long ago, I don't remember how it works anymore. Which isn't very good, but so it has next. What does that do? Pause is less than length. Okay, fine, I guess. So what does peak do? Int pause is equal this dot pause plus offset. Return char at pause. Okay, what does char at do? It just does input dot char at. So I'm not even using the friggin' look ahead buffer. Am I? I'm not even. Wait. Yeah, I'm not even using the look ahead buffer. Of which I literally have. I'm just choosing not to use it. I literally have this look ahead method. But I'm not using it. Oh, no. The look ahead is for the parser? Wait. Alexa dot look ahead. If it's trivia. Wait, this doesn't make any sense. I'm so confused. Have I written this all entirely wrong? How has this even worked so far? Or am I just completely... Have I just completely lost the plot? Because why are these methods not being used? Is next token type? This should be... Like, I don't understand. Okay, here's the thing, right? Look ahead returns... Oh, look ahead returns a token. Okay, okay. Okay, so how this works is look ahead and next token are what's being called by the parser, right? Which is kind of weird, actually, because in reality, the lexing is just done first. They're not happening like sequentially. Admittedly, they could be, but they are not. Yeah, because in reality, the parser should be using the lexer to look ahead, rather than using, I presume, what it currently does, which I presume is a list of things. Like, if I look at build buffer, it's doing... Oh no, it's doing lexer.next token. Okay, I see. I see. Yeah. But like, if I call look ahead, wherever that is, that should actually just call Lexa.lookahead, I believe. Or like is at n should call Lexa.is at n, I guess. But I guess it also doesn't really matter. So yeah, I don't know. Okay, so regardless, I don't really care right now because it's not really an issue. The more important question is why in the flippity fuck is so I think this should be peak 0. I'm not sure. If I do consume and then I peak 0, am I getting the consumed character or am I getting the next character? Chart at pause. I'm pretty sure that gets the current one. Like, pretty sure. It must do. It must get the current one. I look at not that. If I look at consume. Yeah, so that gets oh no. It does get the next one because this increments the pause. This uses the current pause, then it increments the pause, which means actually in reality using 1 ahead isn't going to work. So if I now run it again, don't care. Okay, you're useful to me. So next is somehow still a comma. I'm still confused how that's possible. 0. Okay, stop. 0, comma. Okay, so we're here. Yeah, so we're here. Wait, that's even more confusing. That can't be right. So switch on the next character. If next is greater than or equal to 0. Okay. So while has next character is equal peak. If it's a digit, I don't care. If it's an underscore, don't care. Don't care. If has next and peak 0 is equal dot, no. If has next and peak 0 is no. No. If not, does character terminate number? It should, but let's check. Return character that is white space or single chart tokens. Okay. So then it just returns the token. So that one shouldn't be the issue then, right? Okay, we have another 0 then. So the next is a dot. Okay. So we consume it. And then we read a decimal. So the text is 0 dot. The current is now 0. It is a digit. Okay, so we go next, blah, blah, blah. Boom. Well, has next. So the next one's a comma, and so it should do the exact same termination logic that we had before, hopefully. If has next no. Okay, so it should give me a floating point literal of 0.0. Well, in that case, this looks to be correct. So either it's fixed itself now, or something horrible has happened. Okay, yes, that's worked. We've got a little bit further, so let's go to where we've got to. I mean, there still could be issues in all of this as well. So this isn't like a blanket complete test for if it works. I mean, it would be if I went through and checked if everything's valid, but that would take a really long time. It's better to test it with smaller kind of examples. Okay, let's go to the end and see where we're at. So we're now at 10,200 lines, and we have a null here, which is interesting. So we're looking for not lexeme.starts with. Okay, let's have a look. Not lexeme. Yeah, I mean, it has to be this. There's only two of them, and they're both on this line. So the issue is here. In that case, I assume it's with the backslashing of these, but let's have a look. So what is it saying? So in the then statement, it doesn't know what to do. But that's because we look at the string literal. Yeah, okay, so what it's done is it's saying not lexeme starts with, and the string is empty. So it doesn't know what to do with the string. So basically what that's telling us is this just doesn't mean anything to it. Somehow. Which is kind of weird, because you'd think it would find this, but it obviously hasn't found that. Let's have a look in here. This is going to be really hard to find though. Bugger. Okay. We have to figure out a way that we can determine if we're parsing this or not. I think the best way to do that is also, 1 second. What the fuck is this? What am I even doing here? Why would it start with these? Does it? Does it do that? Is that a thing I told it to do in here? Text block. No, it doesn't. It doesn't even do that. So it literally doesn't start with these. But admittedly, that's probably not the issue. I guess it could be. See, this is actually kind of complicated, because at this point, is the issue this? Like, is the issue because it can't pass this line of code, or is the issue because the parser can't pass this line of code? Like, the parser can't pass the part that it's trying to pass, because the part that it's trying to pass isn't valid to pass. This is blowing my brains. But I kind of know what I mean. I mean, I kind of want to just remove it and see, because this isn't correct, like, at all. Like, it just shouldn't do that. That's just not a thing it should be doing. Just like how if we look at this one, this isn't correct either. This shouldn't have that shouldn't have those either, I believe. And to be honest, there's very few reasons why we ever even need to be looking at those. So let's see what happens now. That might break things, admittedly, but we will see. So that has let it go a little bit further by the looks of it. But no, I guess we'll keep going actually. And we'll see if there's anything. See what the next issue is. Okay, so it's in switch statements. That is the least surprising thing I've heard this year, to be honest. I knew switch statements weren't going to work. I knew that for a fact, so I'm not even remotely surprised. The funny thing is, none of it has worked. It hasn't been able to understand any of it. I mean, it kind of has. So it knows there's a switch statement. It knows we're switching on next char. It knows there's a switch rule, which has a case, which has a pattern, and it's a type test pattern, a class or interface, but then it just dies. It doesn't know what that class or interface is, which is actually not the part I thought it would die on, but interesting. So we just need to look for switch on next char, in theory. So switch on next char, which doesn't exist, I guess. Probably because I think there needs to be a space there. Yep, here it is. Interesting. That's not what I expected. That is not what I expected it to look like. Because for some reason, it thinks it's a pattern. Interesting. Okay, let's look at parse case label. Okay. So what has caused it to determine it's a case label to start with? Because it could be that... No, that looks fine actually. If next to any... yeah. Okay, that looks fine. Okay, first of all, this isn't used. Case label, that should span from... Oh. Well, what does label start, I guess? That's there. That just doesn't need to be a thing though, does it? Like that's... Like I could do that here, sure. Sure, I can do that there, I guess. But like it doesn't need to be in here. That doesn't need to be a thing. There's no need for that. Let's just get rid of that, and then we can span from start like that. That's fine. Okay, but that doesn't solve the issue, of course. So it's trying to pass a case item. I think that's correct, because I think a pattern is a case item. So if we match null, then it's a case null. Else it passes a pattern case item. that correct? Yeah, I think so. So we'll go past pattern. Okay, if we match an underscore, then it's a match all. Okay. If we match... Okay, so then we pass modifiers and annotations. If they're both not empty, then it does that, which is fine. Else it tries to pass a type reference. No, that's not even remotely correct. How on earth did I think that was correct? I'm not handling, like, anything. The only thing I'm handling is types. Right? If I go to implementations, we have a match all pattern, we have a record pattern, and we have a type test pattern. But it's not any of these. Right? Yeah. Wait. It's not a record pattern. It's not a match all pattern. We need to have a literal pattern. Oh no, I guess it's not a pattern, is it? So why does it think it's a pattern? Because we're parsing pattern case item. So we need to have other case items, which we have, and I'm not even using them. We have case constant, and we have case pattern, and we have case null. So am I just not using this? Yes, I'm just not using this. Okay, lovely. So if we match a... That's not a thing you can do, right? Can you do that? Technically, yes. Technically, you can do that. Huh. Not what I expected. Okay. What is a case constant, I guess, is the question. I guess it doesn't matter, actually. Yeah, this is complicated because... Or is it? Is it? I'm just trying to think in terms of like how would it be a pattern versus a constant? Because a constant, even though it's called a constant, can be an expression. So it could be like, you know, you could do switch my thing case other thing dot some method, right? You can do that, I think. Can you? I actually don't know now that I say it. I'm not actually convinced you can. I think you can. I do start dot pause. No, you actually can't. Oh no, it's actually offset. Anyway. No. Wait. No, it is pause. You can't do that. Huh. Can you do variables then? I guess so, because you can do constants, right? Oh, so maybe it does have to be constants. Yeah. But the complicated thing about that is you could have constant, so you can have a class dot constant, right? So I can't just match for just a singular thing. I have to match for yeah, that's actually kind of complicated. But wide, what do you mean? I'm not even gonna read that out loud. What kind of question is that, bro? Are you okay, Wide? Okay. Come on. We can do this. Wait, this is really hard. I need to be able to determine patterns versus constant. But the problem is you could do, like... Yeah, because you could do switch thing, case, you know, my thing dot thing, right? And then you can do like string A, for example, right? Like this. But the other thing you could do is case my thing dot something, right? So I have to be able to figure out, is it this or is it that? But the other problem is you can do case my thing dot thing, right? But so I have to be able to look ahead in a way. Okay, I guess I can do this actually, because if it matches a char literal, a boolean literal, literal. Hello? Why are you not giving me the other ones? Oh, because I need to use match any, right? Or no, if next is next is any. Right, so char literal boolean literal wait, can I just do look ahead type dot is literal? I should probably make that a thing, huh? Is literal. Okay. There we go. So that's all the, I think that's all the literal. Yeah, that's all of them. So now what I can do is I can say if it's literal, then I need to basically pass that. So I need to say literal token. And then I need to return yeah, if it's literal, then I need the expression. and then do a case constant like that. And then, yeah, basically the other thing I then need to do is I need to know, like, if, yeah, basically if it's an enum constant is what I need to look for. So how do I do that? Kind of hard to say. If is enum constant. Alright, good night, Soyabim. Don't pass out, that doesn't sound very healthy. Have you had a nice day? It's been alright. Yeah, it's been okay. Actually, I don't know, I did the announcement of Railroad yesterday. But I've been doing a lot of like admin stuff for Railroad today, just sorting things out. Kind of getting things in a good state. I did also get up quite late because I was a bit lazy. Oh, what are you? So I haven't done a huge amount today, but let's do this actually, and then basically I can replace this with expression, constant expression, and then yeah, there we go. So yeah, I haven't done a huge amount today, but it is what it is. If it is not, if not next to any identifier, no. Wait. Yes. So what does it do? So it marks, then it grabs the next one, then it looks for any comma, colon, arrow, close brace. No. So what it needs to do, it needs to be able to consume multiple identifiers, right? So while next is any, or no, it needs to be do while match dots. Then we need to take the if next. Wait, what? No. We need, if not next is any, if not match identifier, then we break, right? And then is enum constant, we expect a comma, a colon, an arrow, or a close brace. Why would you have a close brace? Oh, because of fall throughs? Is that because of... No, doesn't make sense. How could you have a closed brace? No, this needs to be is switch case, enum constant. Then it's comma, colon, arrow. And then we roll back, return. So basically this will swallow up all of the like, you know, my class dot my inner class dot other class, whatever, dot my constant, right? Or content, whatever. So this will swallow up all of that, and then it checks what the next character is, because if the next character is a comma, then it knows we're looking for another constant. If it's a colon, then basically that is the end. So, you know, obviously this is case beforehand, right? So if it's an arrow, then it's also going to be the end. So comma would be like another one, colon, yeah. But if it's anything else, so say if it's another dot, you know, something dot method, right? Or it could be like if it's no, that won't work. Oh no, it will, because if it's another identifier, right, then that's going to break, because it will have dot, right? So it matches the dot, then it goes match identifier, it does that, then it tries to match the dot, it won't match a dot, it'll match an identifier, so it breaks out of the loop. And it'll come to here, it'll say, what has it found? Yeah. Okay, that's fine. Okay. Phew. Hopefully, if we now find where this is used, which is here, I don't know why it wouldn't show me that immediately, then this should be able to pass constants. Should we try it? Make sure to stay hydrated, guys. Okay, so we've come quite far. Okay. Okay. Where are we at now then? Oh, we are at basically found an else statement and nothing afterwards? Or what? Where are we? So span from, so this is a method invocation. So it thinks it's found span from start comma lexeme comma \0. So span from, no, not like that, we want to do like this, span from start comma lexeme comma \0. So it's reached this. We can confirm that by seeing, are you in a character literal expression? So if we look back here, so if we look for, yes, return character literal expression. Okay, interesting. Is there a string in valid character literal format a couple lines before it? Or the line before it? Yeah, there is. Interesting. Valid, no, it actually does have to be valid, empty character literal. No. Okay, why is this not 2, 3, 4, 5? Okay. So yeah, it's here. It's failing this, basically. As for why, I don't know. My guess is that it can't pass this, right? Because it's completed that return statement, right, from here. And then basically it doesn't know what is coming after this. So it knows there's no else statement. But it doesn't know what to do with this, presumably, is my guess. Now as for why, I don't know, to be honest. Look for char keyword. So is cast? No. Pass class no. Pass non-array type preference. It's probably that, I imagine. Yeah, it's not going to be that. So it's failing here. Okay, so wherever this is being called, which, oh, it could be so many places. This one, probably, and then, okay, I think let's just look for pass local variable declaration statement. Let's try that. I think probably this is failing. Maybe. But why isn't it saying there's anything else? Is kind of weird. Let me run it again. Maybe something happened. No. No? Huh. It's definitely it, isn't it? So do we have a not equals backslash thingy thing? Not equals backslash. Yeah, it's definitely here. It's definitely here. Okay. That looks correct. Object creation expression. So it's returning a new character list or expression, taking in a method invocation expression of span from, taking in the start, followed by a lexeme, followed by a chart, character literal expression, followed by nothing, basically. Yeah, because this is the then statement. So if we go up to here, that's the if statement there. Actually, no, there should be something along this line. Or this. Yeah, after this, basically. There should be something. Wait, no. Wait. If statement. Else statement. Okay, yeah. Yeah, so it is after this, because this is for... Or is this the... This is the children, isn't it? Okay, yeah. Yeah, okay. So, yeah, basically in line with these ones. So we just come all the way down here. And it should be here. But it's not. So it has to be, in my eyes, the only thing it could possibly be is this. Because this is returning fine. So let's plonk in a debug. And how do we even So we could maybe look to see for line 670, but that wasn't reliable last time. So I don't know if I really want to trust it. I guess we could try. No. Okay, let's just friggin' this dot what are we looking for? We're looking for start.pos. Start.line is equal to, what was it, 670? Or something? Is that right? Yes. So if we go back to here, let's play. Didn't find one. Okay. Let's try greater than 600, maybe. Because yeah, it's obviously not reliable enough. So if we look in here, do we have anything in the look ahead? We have two identifiers. We have expression and expression. So let's go up to this one and try and find an expression anywhere above it. Should be there somewhere, I imagine. I hope. Oh, weird. Unless it's here. Maybe? I guess let's look at what the next one is. That's also expression though. Funny enough. Oh no, it's not. Never mind. So it is report error. No. Wait. Maybe. No. No. Shouldn't be. No, it shouldn't be. Okay. Next. Expression equals. Okay, there aren't many. There's actually only one of those. That can't be right. Oh, no. It's expression equals like that. Okay, there aren't too many of these either. The previous token was an open brace, apparently. If I do a regular expression, I can do \s plus. Doesn't like that because of this. Okay, there aren't many. So it could be one of these. Could be any of these in reality. Yeah, it shouldn't be any of those though. Let me turn this off for a second so I can find the actual one it's meant to be. Which is here, which is 670. So according to that, we're nowhere near. So let's keep going. Gonna take a while, unfortunately. Expression equals var. It's gonna be really hard to figure out. Okay. There must be a better way to do this. Maybe we can step inside of here and we can try and figure out what it's found. Maybe. So Yeah, like possibly if we maybe breakpoint here and we say next is any char keyword, that might work. So if I press play, okay, it has hit something. So if we look ahead, whoa, why is the look ahead 10,000? What? It has found char C is equal something. Okay, why has it done that? Char C. Okay, according to that, it's here, which doesn't make any sense. Interesting. Okay. What is it gonna do next then? If you look at here, what does it do? It has the type, which is a primitive type. Okay. So if next is any identifier, which it is. Okay. So then we roll back. Is variable declaration is true. Okay. So that means it's a local variable declaration. Boom, boom. Okay, I don't think this one's the issue. Let's keep going. So next we have char next char, which is here. Wait. Wait. Are we not already past it? What are we even looking for? Are we looking for char? Or am I crazy? Char? Are we look? I swear we're looking for char. No, we can't be looking for char. That doesn't make any sense. What were we looking for? Okay, all I know is we were looking for this. So I can find this again. Okay, we're looking for char value. Char value. Okay, 675 is what we're looking for. Okay, so let's press play again, because that can't be the right one. Okay, somehow... What? Doesn't make any sense. Okay, look ahead buffer. So we got char C. We know it's not that. Char next char. We know it's not that. What? Huh? What? Char next char. But we know we're past this, right? Right? I think we have to be. That's 623. So if we go up like a little bit, it's kind of hard to figure out exactly how far. Let's find char at. And that'll be like roughly. So that's lexium.char at. So or lexium.char at? No. Be a local variable declaration. Lexium.char at, which is a binary extract. No. Not correct. It's not that one. Is this one? Lexium.char at. Char next char is equal lexium. Okay, yeah, it's not that one. It's obviously not that one then. Okay, the other thing we could do... Okay, there's another solution actually. What we could do is, since we know we're getting the error from... Where is it? I've lost it again. From... I actually have lost it again. Oh, here. We're not getting the error from this, right? So if we find a string literal being passed that has this value, we should just be able to kind of like step over from there, in theory. So if I find string literal, which is here, it's going to be jank, but this should work. So if we, not that one. So here, and we breakpoint saying value builder dot toString dot equals that. And basically what that should do is it should only hit that breakpoint when we are the line before what we think might be erroring. So if we step over, boom. Okay. No. Boom. Basically go until we reach the next one. Somewhere we should find the expression statement, at which point it should hit a semicolon, and then it knows to go on to the next expression. Hopefully. That's the theory. And then we can figure out exactly what's happening. So, pass expression, which is... Oh, of course. Yeah, we're going to have to go through all that again. Because that's inside of a method invocation. Right. So we're going to have to go through all of this again until we hit a semicolon. I don't want to go past it is the only problem, but we have a little bit of a way to go. Okay, here we go. Semicolon. Boom. Okay, so. Oh, shit. When it comes out of this lambda, is it going to go back to here? I think it will. Yeah, it should do. Yeah. Okay, good. So that passes the statement. Boom. Then we have the next one. So we need to step into pass statement. Okay, now we should be able to see what the next one is. If we... Why is the look ahead so friggin' large? That's kind of concerning me. That's actually like very concerning. Because that shouldn't do that. I don't know. We obviously have something somewhere that's not doing a look ahead correctly. Okay, so it's passed a return statement. Let's see what it's actually got back from us there. So statement, yeah, I mean, this is all fine, right? Let's just see what the look ahead. Oh. The next token is end of file. What's in the diagnostics? Interesting. Very, very interesting, huh? Okay. So the issue is with the return statement. Interesting. Very, very interesting. But that's weird. So somehow the return statement is consuming 10,000 characters. That singular return statement. No, not even 10,000 characters. 10,000 tokens. It's consuming the entire file. How? How is that possible? Let's have a look at it again. And let's try and figure out why. Like, why? So, return statement. Well, unless it's the then. No. It shouldn't be the if statement doing that. Unless. Can I see the previous token? Closed brace. Not really helpful then, is it? This is going to be really hard to do because now I kind of need to do that entire thing again. Okay. We have 7 minutes. We're going to have to go do it again, unfortunately. So, we're here. We know this one is fine, though. So, basically, we want to step over until we reach statement. So, once again, I don't want to accidentally go too far, but... Okay. I'm just looking through down. Oh, you can't see what I'm looking at. No. My just can go up here. I'm looking at this down here, by the way. I didn't realize you guys can't see that, but yeah, you can't see that. Actually, I can do step out, can't I? Yeah. If I go here. Okay, so yeah, step out of that. Step out of that. Okay, so that gets us the statement. Okay, so then we go ahead again. Boom, boom. And now it's going to try and pass the next statement, which is the problematic one. So, we're not going to match a semicolon. We're not going to match any of these. What are we trying to match? We're trying to match return, right? So, let me just double check exactly what we're trying to match so that I know exactly what we are looking for. So, I'm going to take this. I'm going to plonk it in a notepad on my other monitor. So I can look at it and remember that that is what I'm looking for. So, where are we right now? We're here. Okay, so not you, not you, not you, not you, not you. Yes, you. You'll be the one. Let's step into you. Okay, so we expect a return keyword. True. Then, if next is not a semicolon, correct, then we're going to pass an expression. Okay, so, is lambda header? No. Step into. Then we want conditional. Then we want this conditional. We just basically want to keep going into these. So, do this for a while. Basically as far as it goes. Yeah, keep going, keep going, keep going. Okay, so if next is plus plus, no. Next is open. Okay, what is the next one, by the way? Let's have a look. Next is new. So we're going to keep going. Step into. Okay. Oh, shit. Fuck. I didn't mean to do that. That's probably just fucked up the entire thing, hasn't it? Because if we see... Yeah. Okay. Okay, actually... Maybe we can do it the other way around. Maybe we can look for a new object creation expression. Right? So if we find... Parse class instance creation expression, right? And then in here we say next is any character literal expression, right? No, next. Oh no, how do we do that? Shit. Look ahead. Look ahead. 1 dot lexeme dot equals that. Boom. Okay, whatever. Get out of here. What? Wait. 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 What do you mean? What do you mean? Oh, we're here. Wait, I don't... Wait, what? How are we there? Wait. I'm so lost right now. Object. No, where is it? Yeah, this. Class instance creation expression. How is that not being hit? What? Look ahead 1 dot lexeme that equals character literal expression. What? Oh, because I've done it here. It's actually look ahead 2, technically. I think that's why. Is that why? No? I think it is. Look ahead 1 dot lexeme dot equals character literal expression. What? Okay, that means it's failing before it's reaching this method? Which doesn't make any sense. Object creation expression, which is here. Oh. Wait. Past classes. Right, yeah. But that means it's getting into here. I'm so confused right now. I'm actually so confused right now. What? It's literally right here. Object creation expression, which is creating a new character literal expression. How in the flippity fuck? Okay, maybe what I can do... Okay, maybe there's a different solution. Maybe I could put a breakpoint where I know it will exist. which is parse return statement, right? So here, it should look like, look ahead type 1, or next is any return, and next is any at 2 new, and next is any at 3 identifier. That'll find me all of the return new XYZ, which is going to be a lot, but it should be good enough, I think. So if I open these, I should be able to see what it's finding. So return new assignment expression. Don't care. Don't care. Don't care. Don't care. Don't care. Don't care. Basically, I'm just going to continue until it finds an object. No, what are we looking for? Character literal expression. So string literal, string literal, string literal. How are they all string literals? Is that correct? Character literal. Aha! Is this correct? Span from start, comma, lexeme, comma, \0, close parenthesis, semicolon, close brace, char, identifier, semicolon. Okay, we're here. That worked. So, expect return statement. Yes. If next is not a semicolon, then we want to pass an expression. It's not a lambda header. Step into. Step into. Step into. Step into. Step into. Step into. Boom. 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 Okay. I'm not going to keep saying boom. Let's try and find the little bugger. So we're looking for new, and we're going to try very hard not to skip over it this time. We want to go into this. So this, no. Literals, no. Open parenthesis, no. New, yes. Okay, let's open all of this as well. We can see in here what we have. Okay, that didn't really help. So we're looking for an identifier. Okay. We should be able to go into this and it should be able to pass that for us. Don't know why it wouldn't. Okay. Okay. So annotations. We should be able to get the identifier, which is that. Correct. Gives us the name expression. Okay, and then that comes back to here. So next is an open parenthesis. So it should go into here. Okay, so we have all of these. Look, the look ahead is still fine. Okay. So what is after? We have span from start. Okay, I think I know where the issue is. But we'll have a look at it in a second to make sure. So arguments, expect that, then we're gonna pass an expression. I'm actually gonna... No, we'll go into it just to make sure. Just to make sure. It's going to take a little bit longer, so this stream is actually going to overrun a little bit. So, well, we've already overran a little bit, but we just need to freaking figure this out, because I can't kind of leave this halfway through, because I will come back to it and I will have no idea what I'm doing, and we'll have to go through this entire thing all over again, and I don't particularly want to do that, so that's why we're going to try and figure it out right now, even if it means it takes a little bit longer. So this, littles, don't care, open parenthesis. No, we're looking for the identifier. So not you. Not you. Not you. It's you. So, we expect the identifier. Okay. Then we match an open parenthesis. Then we want to finish the method invocation. So let's go into there. Okay, then we are passing a name. This should be fine. Pretty certain that hasn't fucked anything up. No, that's fine. Because that's just a name. There's nothing special about that. That comes back to where it was. So we just need to go through these for a little bit. Make sure I don't accidentally hit the next one, which is what? What is the next one? The next one is a comma followed by an identifier. Okay. I think I know what the issue is, regardless. But okay, so let's just step out for a little bit, and we'll get back to where we were, which will be here. So the next one will be ignored. I don't care about the next one. So with them, we're going to go into this one. And I think the issue is in here. So let's go past conditional, past logical. We're going to go all the way down to primary. Again, as we do most of the time, to be honest. Keep going. Boom. Okay. All the way down. We need to go into postfix. Just check that in the look ahead we still have the character token next. I'm pretty sure the issue is with the character, by the way. So no, yes, it is that. I almost stepped straight over that, but yes, it is a literal. Okay, so is it a null literal? No. Is it a Boolean literal? No. Is it a character literal? Yes. Okay, so let's go inside you. Okay, char token. So we should have the lexeme. What is the lexeme? Oh, interesting. Oh, the lexeme is like this. It's with these. Lexeme, yeah, it has the, you know, the little things, whereas the strings don't. Funnily enough, that should probably be fixed, but I guess it's not a huge issue. Interesting. So that should be fine anyways. So if lexeme.char at 1 is equal backslash, that should be true. Lexeme.length is equal 4. 1, 2, 3, 4. That's true. So then we're going to switch on the char at 2. 0, 1, 2. Ah, I'm not handling null bytes. That's why. Am I not handling anything else? No. That's why. All of that just because I wasn't handling friggin' null bytes. That's kind of crazy. So hopefully that gets us a little bit further. Yes, it does. Where does that... Oh, that went really far. Oh, baby. Okay, I don't know why I said that like that. I sincerely apologize. I'm sorry, Wide. I don't know why it came out of my mouth like that. Where are we at? Past class body declaration. That's quite far down, isn't it? No, not really. Okay, we're here. Which this is, admittedly is quite complex. What it's got here. It should be fine. I mean, this isn't anything it hasn't done before, I guess. Like, it's an instance of, it's a ternary. The method calls. It shouldn't be able to not do any of that. What's after it, I guess, is the important question. This. Huh, okay. What is actually happening then? Let's have a look. So, we got past class body, which in the arguments takes in an instance of, so type is instance of class or interface type reference, called class or interface type reference. Correct? Okay, what's the true expression? So, method invocation, method invocation, method invocation. So, class or interface type ref dot parts dot get last dot name. Yeah. Okay. In the false case, it is null. And then the next, I assume, argument is false. Huh. So, huh. I don't know. At last, Herod. Yeah. Or, it, stopped being able to pass on the following line. Need to investigate why. Sure, I guess. And we'll come back to that tomorrow, because obviously I'm streaming tomorrow as well, also at 7 PM. So it won't be a surprise why, because I just told you. So you cannot say it's a surprise. Okay, let's just quickly push these changes. So what have we done? We have made some fixes to the parser and Lexa. Sure. I don't know exactly what I've done, to be honest. I don't remember everything I've done. But there we go. Pushed. Done. Okay. I'm going to go ahead and end the stream here. I hope you all enjoyed. And I will see you all tomorrow. Good. Bye.